Hello, this is Jake and Neil. We're going to be presenting our CS42 final project on Capture the Flag cybersecurity competitions. So quickly, a Jeopardy-style Capture the Flag competition is what we're interested in. So just like the game show Jeopardy, you're given an assortment of challenges in different categories with varying point values based on their difficulty. But unlike Jeopardy, you can solve them in any order. You don't have to wait for someone else. It's not structured like that. You're just given all of the challenges and you're going off to solve them. So after you solve a challenge, you submit a flag to the leaderboard and then you're awarded those points for solving the challenges. So specifically, we're interested in this because of our involvement in SIGPODI, which is the cybersecurity organization on campus here. And the things we're looking at is trying to see the impact of challenge selection, so how you decide to allocate your time, like how that impacts your scoring
All
potential.
challenges are released at the very beginning of the competition. And then teams are able to view a public leaderboard throughout the competition, which does have the points at that specific time. And they can view this all the way up until closing. So moving on, here is the layout of our CTF competition. So as you can see, there's a couple of states here, such as the initialization, the select, the finish, the hoard, and the observation. So initialization is pretty simple. It's just when the competition is opened and teams now may start solving challenges. Select is then scheduled, and then hoard is also then scheduled at the hoard time, which is coded into our simulation. For select, each team kind of selects a challenge to work on. This is either through the smart or the random selection that the team might want to implement. We talk a little bit about this more in our results. And then finish is when the team has either successfully finished or has failed the challenge, but has finished that specific challenge iteration. And so if any remaining challenges are left for the team in that category, then select is immediately scheduled after finish. And then at Hoard, the top team may select to withhold their solutions or their kind of results from the leaderboard, and that would kind of update the board status for the top team. And then at observation, this is 3 hours from close. The current standings are recorded for any analysis. So here is kind of the same thing that I've talked about, all of our events in our system: initialization, select, finish, hoard, observation, and completion. This is also detailed in our report. For verification and validation, we kind of draw on our experiences from CTF events and the plethora of past CTFs, which do have published leaderboard data. So we're able to kind of look at our data, look at our graphs, and see how kind of it validates whatever claim that we have, since the public data is also kind of on a similar pattern. So many teams kind of tend to solve easier challenges first to maximize the score, and then the score rate kind of levels off as we go on, which we can also see with our specific results on the right image. For verification, we use a lot of libraries. So we use NumPy and SciPy specifically with Python for kind of ensuring correctness with any calculations or anything of that sorts. And so we kind of reduce the amount of calculations we perform manually for this. And so we do have a verification and validation techniques implemented. Thank you.
So now to move on to our results and analysis. So the first output that we're interested in is trying to see how the points earned for a single team varies based on their selection strategy, whether that's smart selection or random selection. So, as described earlier, you're given an assortment of
I have
challenges
no
with
idea. It's
varying
like
difficulties
at
and
like
points.
15%.
So smart
the
selection
circle.
strategy would involve trying to maximize your points by solving challenges that give you the most amount of points for the least
This is
amount of
on
time
medium.
solved. And then a random
low to
selection
very.
strategy is pretty much just indiscriminately
Yeah, I took this
selecting a
long last time.
challenge,
That's why
which
I overshot it.
would
It
allow you to
took,
waste
I
a lot of
submitted
time
310.
solving challenges or maybe even failing to solve challenges
Wait, I'm gonna try. I think
that are
we should
beyond
do
your
this.
difficulty. So we see quite a significant gap here. In our first result, the
Now
smart
it's on
gets
25.
around 3,300 points.
The random gets around
And
1,800.
the random gets around 1,800.
To try to
we got pretty good
to try to
variance here.
we got pretty good variance here, but to try to
in our
improve
second
it
table,
further,
we use
in our second table we use antithetic random numbers
random numbers
for various
iMovie.
random number
iMovie.
streams are used in the
This
simulation.
has a pretty large
And we see that
effect
this has
on
a
the
pretty
variance,
large
more so than
effect
you'd
on the
expect from
variance,
just doubling
more
the
so
number
than
of
you'd expect
challenges,
from just
which
doubling the
validates
number
that
of
there is, in
challenges,
fact,
which validates that there
pretty
is in
negative
fact
correlation between
Alright, we're
these
like
negative
40% right now.
correlation between these samples.
And then for the last
Sample run.
It's speeding up. It's
And
speeding
then
up.
for the last
we're using
table here,
common
we're using
number stream
common
between
number
the,
stream
smart and
between
random
the
challenges,
smart and
so
random
that we
challenges,
could actually do better.
so that
Like
we can actually do
245.
better than just subtracting the mean and then assuming independence for their variance. We could actually subtract correlated runs,
using the smart
which would be the
and
ones
random
using the
trials.
smart or
So for
and
the
random
first one,
trials.
we don't use any.
So for the first one, we don't use any antithetic
runs, and that has a slighly better variance than
and
you
that
would
has a
get from
slightly
just
better
the
variance than you would
naive
get
method I
from just
described
the
earlier.
naive method I described
And
earlier.
then the
And
antithetic
then
trials actually has about the same
antithetic
variance
trials actually has
as,
about the same variance
if you were to
as,
assume independence.
if you were
So
to
then,
assume independence. So
Moving on to
then,
our next result, we're looking
moving on
at
to our
the
next
leaderboard
result,
stability.
we're looking at
So
the
the first
leaderboard
table
stability. So the
includes
first table
teams never hoarding.
includes teams
So you
never
see we have
hoarding.
Wait, what if we submit
So you
right
see
now and
we
then
have
I
fairly
give the link
stable
later?
rankings, everything around the center diagonal, which means that teams
Yeah, we could just say like forgot to attach link or something.
are just staying around where they placed 3 hours earlier. Which makes
Yeah,
sense
yeah. Can you
because
submit
there's some
the
variance
report
in
and the
teams
code,
solving
and then I'll
challenges
attach
or
the link at
whatever,
like
but
3 o'clock.
no deliberate manipulation of the
In, like, a
leaderboard.
comment.
However, the second result, we have a 50%
Yeah, dude,
chance
they have to say
that
that, like, come on.
team will decide, the top team 17 or say 16 hours
Yeah.
from close will decide to hoard
Just making sure we
flags
have the report and everything in
withhold
it
their
by, like,
true
so.
volume of solved challenges. Just visualized on the right as you see the pink team, team 6, around 16 hours from close.
Go dark.
They decide to go dark and
until the
don't
very
submit
end,
any flags
which would
until the very
surprise many
end,
teams
which
and,
would surprise many
randomly
teams
overtaking
and
them. So you see that's
randomly
why there's that
overtaking
sort of
them. So you see that's
yellow
why there's that
patch
sort of
towards the
yellow
middle
patch
left
towards the middle left of our
It's fine. It's fine.
table. We neglected or declined to include the confidence
submitting right
intervals
now?
on these slides because they're quite unwieldy to look at, but they are in our final report. Now going on to our methods for interval estimation. Use the
Okay.
standard sample mean and variance formulas shown on the
And
right.
then we also use the
And
standard
then we also
T
use the
distribution
standard
method as we don't
T distribution
know the true
method as we
sample,
don't know
or sorry, the true
sample,
population
or sorry, the
variance.
true
We know the
population
sample
variance. We know the
variance.
sample
So we have to use this
variance.
for
So we have to use this
And we are
for
using
correctness. And we are using the central limit theorem here in some sense for this. And then
we also use
we also use the Klopper-Pearson method for binomial confidence intervals, which is
previous result look at
the
leaderboard
previous
stability.
result look at leaderboard stability because you either are in the given place, given that you're in that place prior, or you're not. So this is a basic binomial distribution. However, we could not
the entirety of how this method
include the
works
entirety
on
of how this
these
method
slides.
works on these
Instead,
slides. So instead, we link to the SciPy docs in our final report.
So to conclude, teams should
So to
spend a lot
conclude,
of
teams
time
should
carefully selecting
spend a
which
lot of
challenge
time
will gain them the
carefully
most
selecting
points.
which challenge will gain them the most
Like 80?
points for the least opportunity cost, meaning they could be spending time
Earlier,
elsewhere.
it has a
Because as we
massive
saw
impact
earlier,
on
it has
your
a
score.
massive impact on your
Teams
score.
cannot rely on the scoreboard.
And teams
to judge
cannot
their
rely on
lead
the
and
scoreboard
relax
to
their
judge their
play.
lead
Because
and
it can be
relax their play
deliberately
because it can be
manipulated, as we
deliberately
saw.
manipulated.
Yeah, I got that open.
And as we saw, it has a large effect
And
on
it
the
can
ranking.
drastically change
And it can
towards the end.
drastically change towards the end.